calculate the angle of incidence of a beam radiation on a solar collector located at Kati, latitude 17.45 degrees on June 15 at a solar time of 10:30 a.m. It goes on and say the collector is tilted at an angle of 20 degrees with the surface azimuth of angle 15 degrees. So dealing with this one, in calculating the angle of incidence of a beam radiation, these are solar calculations. So when dealing with these type of questions, only the formula will lead us first. So in this scenario, our formula says cos theta is equal to sine sigma sine phi cos beta minus sine sigma cos phi cos gamma plus cos sigma cos phi cos beta cos omega plus cos sigma sine phi sine beta cos gamma cos omega. So the question, the formula goes on and on and on. It's a bit long. We shall express it in full in the following. So this is the formula. This is the setup of the formula. So the complete formula says cos theta is equals to sine sigma sine phi cos beta minus sine sigma cos phi cos gamma plus cos sigma cos phi cos beta cos omega plus cos sigma sine phi sine beta cos gamma cos omega plus cos sigma sine beta sine gamma sine omega. So this is the whole complete formula to calculate the angle of incidence, where our theta is our angle of incidence. So as we tackle our question, for it to be easier, we have to list all the necessary information that we have and find out what we don't have and calculate and have our solution. So moving on, our given data, theta, which is the angle of incidence, is not given. This is where our question is. Our phi, which is our latitude, we are given as 17.45 degrees. Our beta, which is our tilted angle, we are given as 20 degrees. Our gamma, which is our surface azimuth angle, we are given as 15 degrees. Our angle we are not given, but you can find it from the solar time by multiplying 15 degrees, which are 15 degrees per hour per rotation of Earth, 15 multiplied by the number of hours before. If our solar time is afternoon, if our solar time is before noon, we multiply by the numbers before noon. If we are given, like in this scenario, we are given 10:30, we calculate from 10:30 to 12 o'clock. If we are given time that is above 12 o'clock, we calculate coming back. Let's say we are given 1:30 p.m. We calculate from 1:30 p.m. all the way up to 12 o'clock. So in this scenario, our hour angle will be calculated as 15 multiplied by number of hours before noon, because it's 10:30 a.m. So the number of hours before noon will be 1,5. So our hour angle, which is omega, will be equal to negative 1.5 multiplied by 15, which is equals to negative 22.5 degrees. Why negative? If you are given your time and it's before noon, it's a negative, and if it's afternoon, it's positive. I'm sure I'm clear on that one, so that there will be no questions. Now, what other parameters do we have? We have the nth day. Nth day, we can calculate it from June 15. Then we may have the nth day as 154. Our nth day is 154. Then the other parameter that is left now is the declination angle, and the declination angle is represented by the letter or simple sigma. Now we have to determine the declination angle. We did this in a series of videos that we did before. You can go and watch them and get familiar with this. So in this video, we just are going to run through it a bit. Its formula is this one. So substituting the values, n, we have n as 154, putting 154, we have sigma as 22.30. So continuing with our question, now we are able to calculate the angle of incidence of a beam radiation. Why? Because we have all the necessary requirements. So we are now not going to write the formula again. You can refer back. If you want, you can challenge and pause this video and try it out yourself. So writing our solution, cos theta will be equal to sine 22.3 sine 17.45 cos 20 minus sine 22.3 cos 17.45 cos 15 plus cos 22.3 cos 17.5 45 cos 15 cos negative 22.5 plus cos 22.3 sine 17.45 sine 20 cos 15 cos negative 22.5 plus cos 22.30 sine 20 sine 15 sine negative 22.5. By punching in all these values in a calculator, we got 0.811466. So calculating our angle, it will be the second function of cos or cos arc 0.811466, and we got 35.76 degrees. So here we go. Our incident angle of a beam radiation is 35.76 degrees. So simple. Thank you for watching this video. I hope you find it informative and simple. I thank you.